Okay, time for Friday asynchronous December 4th YouTube lesson, and we're going to 11.4 today. We're skipping over 11.3. I needed to get one more day out of the curriculum somewhere, and 11.3 didn't make the cut. So we're jumping it, moving on to 11.4. And that will allow us to get through the whole curriculum before the end of the semester. And so 11.4, as you can see here by this grid, is all about graphing quadratics. So the different translations and transformations that we see when we graph quadratic equations. Why can I not move this? Thank you, Microsoft. There we go. Don't know why it wouldn't move before. All right. So to start, most of what this lesson will be about, whoops, that's not what I meant to write, is example problems. I think, with graphing, the really only way to see the pattern is to see a few examples in action. So it's mostly going to be about examples, but I just want to start with the basic pattern of quadratic graphs, just the basic parabola. We've seen it before, but just to refresh ourselves on the basic shape of a quadratic equation. So remember, a quadratic is when we have an x squared as the leading polynomial, and then we might have like a plus something times x and then plus a number. But the most basic quadratic is just x squared all by itself, right? Because then, if you recall to the 11.2 lesson on the quadratic formula, our b would be 0 and our c would be 0 in this case. That 0 kind of looks like a 6, but it's a 0. So that is the most basic possible quadratic equation. A equals 1, b equals 0, c equals 0. So let's get rid of all this extra stuff we don't need. And let's just look at the basic shape. So when you're graphing something, in my opinion, I like to just plot several points and then connect the dots. So start with 0. X equals 0. 0 squared is 0. So we can plot that, 0, 0. The most simple number after 0 is 1, and 1 squared is 1. So we plot that point. Now let's go to the left, negative 1. Negative 1 squared is also 1. So we plot that point. All right, let's keep rolling. 2 squared is 4. So we come right up here to 4. And negative 2 squared is also 4. Come right up here to 4. So let's expand out a little bit. Let's check out what 4 squared is, right? So if x equals 4, 4 squared is 16. Now that would be kind of way up here, right? So we've kind of gone off the grid, but we can kind of guesstimate. So there's like 10, 11, 12, 13, 14, 15, 16. That's reasonably close. So like way up here, except it didn't draw the dot for me. That was a little weird. All right, there it goes. So you can see that, as Ron Burgundy says, that escalated quickly. It started off just going up by 1, and before you know it, we've shot off the grid there. And on the way, we hit 3 squared, which is 9, so we can actually plot that here. And we also know that negative 3 squared is 9 as well. So there's our basic squared shape, and if we kind of fill in the blanks here, you can see the classic parabola going up there. So it starts off small, but it gets bigger quickly and in both directions. Had a little stutter there. But it gets bigger quickly in both directions. So the negative side starts going up quite fast, and the positive side also starts going up quite quickly. So there's our basic shape, and now we're going to do some manipulations to that basic shape. So let's start with some examples. The first problem from the assignment, number 11, tells us that f of x equals x squared plus 2. So what that is a quadratic in the form, wow, my tablet's being particularly irritating tonight, but it's in the form of x squared plus k, not h, sorry, h comes later. We want x squared plus k. So what that means is move up by k. So we've taken our regular x squared graph here, this general parabola, and we've moved it up by 2. So everything got shifted up 2. That's what that is. So if you have k, or if k is negative, it means you get shifted down, right? If k is negative. So I'm going to move up by k or down if k is negative, right? If k is less than 0. So if it was like x minus 2, then we would take our graph and shift it down 2. So that's all the x squared plus k type of graph is it's taking our basic x squared graph here and just moving it up or down. It doesn't move left or right in this case. So let's take a look and see what that looks like here. So originally we started at 0, 0, so we move up to 0, 2, if my tablet would allow me. Same thing, we were at 1, 1, so we move up to 1, 3. We were at 2, 4, so we move up to 2, 6. Oh my goodness. I was worried that graphing on this tablet would be a pain. It's not letting me do anything. There we go. And then we had 3, 9, so we move up to 3, 11, which would be, here's 3, 10, so just a little bit above that, something right around there. And then same thing on the other side, because it's a mirror image here. So 3, 6, 11, and then we draw in our parabola shape. Just like that. Sorry, it's I'm not particularly good at drawing graphs to begin with, and here I am trying to use the stylus on this tablet that likes to freak out and bring up menus. So it's not very pretty, but you can see how number 11 is just our basic graph, but we moved it up. So numbers 11 through, numbers 11 through 17, excuse me, are just that, taking our basic graph and moving it up or down. Let me make sure I didn't just lie to you really quickly. I'm pretty confident what I just said is correct. Yes, it is. So the first chunk of problems in today's assignment is just taking our basic x squared graph and moving it up or down by however many units as dictated by k. So pretty straightforward stuff there. That's definitely the simplest translation, is just moving it up or down. So now if we go ahead and look at number 19, right, the next chunk of problems, then we see here 19 r of x equals x plus 1 squared. So it's a quadratic, right? Because our x term is squared. but it's bringing this 1 along with it. So it's not in the form of x squared plus k, because now the constant has moved inside the parentheses. So it's being squared 2. So when that happens, we get something in the form of, if it would please stop selecting that picture, that'd be nice. F of x equals x minus h squared. And so what does that mean? This is a left or right movement of our basic x squared graph. So we take the basic x squared graph and we move it left or right. So if you have a subtraction problem, right? If you have x minus h, you are moving to the right. And yes, I know that seems a little counterintuitive. Usually we think, okay, negative going to the left, but in this case, it's hard to explain. I was dreading getting to this point, and I was like, hopefully I come up with a good way to explain it here. And it's one of those things that makes sense as you do it. It makes more sense as you do it. But essentially, right, we think of the most basic point is the origin, 0, 0, right? If we look back at our basic graph here, when x equals 0, then y, or f of x, equals 0. So when we come down and we see this form, x minus h squared, right? We think, okay, how have we moved from 0, 0? So for instance, so let's say h is 1. So let's say we've got something like x minus 1 squared. Then in that case, how can we get back to 0? Well, in that case, x would have to be positive 1, right? Because it has to move us back to 0. That negative 1 has kind of brought the sway of things over to the left. So in order to compensate that, we have to shift our x's over to the right. That's not exactly how I wanted to explain it. Coming out of my mouth, it doesn't sound quite right, but that's the best I can really do. I can't think of a better way to explain it than that. It's just when x gets altered in some way, so in this case, like we've added 1 to x, we haven't added 1 to the entirety of x squared like we did up here with the 2. We've modified the quadratic function itself. So x and 1 together get squared. So to kind of adjust back to normality, you kind of have to shift to the right to or shift to the left in this case, excuse me, because we're adding. So we have to kind of shift to the left of our x because now our equation has been boosted by 1. Again, it's not coming out right. So why don't we just get to the examples and see if it makes more sense that way as to why we move to the right when we subtract, or if we add. So if we add h, you move to the left. So if this is a addition, like it is here in number 19, we move to the left. If it's a subtraction, here, if we've got x minus something in the parentheses, we move our graph to the right. So again, here's our graph. And let's get rid of this here because this was just an example I was using. That's not the actual problem we're graphing. Number 19 right here, r of x equals x plus 1 squared. That's what we're actually graphing. So let's focus on that. So x plus 1, addition. So we're moving to the left. So our basic graph starts at 0, 0. We're going to move that to the left 1 to get us to negative 1, 0. We've moved it to the left. Same thing, we usually have negative 1, 1. We're going to move that to the left. we usually have -2 squared is usually 4. And we're going to move that to the left. So we just keep, so all of our normal numbers, we move 1 to the left. So we usually have +1, +1. So let's move that to the left by 1, because we do it by 1 because it's x plus 1 here. If this was like x plus 3, we'd move to the left by 3. Right? And let's double check that, right? Is f of x, or in this case r of x, equal to 1 when x is 0? Let's double check. Well, when x is 0, then we get 0 plus 1 squared, which is 1. So yes, indeed. So now we have graphical evidence that we're correct. So when you've got addition, you go left. When you've got subtraction, you move right. So we used to have, okay, I'm tired of this coming up, so I'm going to see if I can, there we go. I think that should fix my problems. So normally we have 2, 4, right? 2 squared is 4, so we move that to the left 1. So now 4 goes with 1 instead of 2. Same thing, 3 squared is 9, so we're going to move that to the left. So now 9 goes with 2. So everything just got moved to the left by 1. Never mind, the menu's still popping up. All right. And now draw in our parabola. And one thing to note on these problems, the line of symmetry is no longer the y-axis, right? In our first two examples, in the basic x squared example, and in number 11, the center was the y-axis. The y-axis went right down the middle of our parabola and split it in half. When we have one of these x minus h squared situations, we've now moved the middle of our parabola off of the x-axis. So in this case, it's x equals -1, right? So x equals -1 is now what we call the axis of symmetry, which is basically just a line that splits our parabola in half. So every parabola will be symmetrical. I shouldn't say that, actually. I might reel that back a little bit. But the parabolas we're going to talk about today are symmetrical. And you know what? I'm gonna go ahead and say that all parabolas are symmetrical, because I don't like saying things so definitively like that, but running it through my brain, absolutely that's the case. Right, I knew that. Okay, I just double checked to make sure I wasn't leading anyone astray, because, you know, that would be poor practice. And indeed, all parabolas are symmetrical, and I knew that. I don't know why I doubted it. So they all have an axis of symmetry, and it can be the equation for your axis of symmetry, in this case, the line x equals 1, can be found by looking at h, right? So in this case, our h was -1, because we have x minus h. So how do we turn a minus into a plus? If it's negative. So number 19 here is just like saying x minus -1 squared, right? And then when you minus a negative, it becomes x plus 1. So h in this case is -1, which is why our axis of symmetry is x equals -1. So we have moved off of the y-axis now. The y-axis is no longer our center. It's no longer our axis of symmetry. And that's going to come into play later on when we get to number 45. So we've talked about moving up and down. We've talked about moving left and right. So what about getting skinny and getting fat? That's the next two ways we're going to edit our quadratic graph here. So number 29, f of x equals 4x squared. So a few things, right? If you just have f of x, so our basic shape here is ax squared, right? We don't have any b or any c in this case. It's just something times x squared. What's that going to do to our graph shape? So if a is, and let's start with this. If the absolute value of a is greater than 1, then it gets skinnier. If the absolute value of a is less than 1, so if it's some sort of fraction like 1/2, -1/2, -3/4, whatever, if it's smaller than 1, it gets fatter. And if a is positive, whoops, so positive starts at 0. So if a is greater than 0, then it's an upwards facing parabola. And if a is negative, then you get a downwards facing parabola, where the center is at the top instead of at the bottom. So those are some of the possibilities here. So now let's look at number 29. So number 29, let's get ourselves a graph to work with here. And hopefully this graph is a little more friendly than the graphs have been so far. And there we go. So let's do what I like to do here with, we've got x, we've got f of x. Let's make a little chart. And let's start at 0. And 0 squared is 0 times 4 is still 0. So we're still on the origin here. So we haven't moved anywhere yet, right? Regular x squared, 0, 0. 4x squared is still 0, 0. So now let's see what 1 is. 1 squared is 1 times 4 is 4. So we've zipped right up there even faster now. And let's see what happens when we go with 2. 2 squared is 4. 4 times 4 is 16. And we're already off the grid, right? We're already up here. 10, 11, 12, 13, 14, 16, somewhere like something like that. Way up there. And then same thing on the other side, right? Because it's symmetrical. So we've got -1 is also going to be 4, because -1 squared is +1. +1 times 4 is 4. And same thing with -2 is going to be 16. So -1, 4, -2, 16. We're kind of encroaching on this graph up here now. There we go. Something like that. And you can see this parabola comes down here really quickly, makes a very sharp turn, and then zips right on up here, right? So you can see that in the case of number 29, we've got 4, which is a positive number. So we've got an upwards facing parabola, and 4 is greater than 1, so it gets skinnier. You can see that, right? This tall, skinny parabola here versus our original parabola is a lot wider, right? Like this one's wearing the 34-inch waist. This one's wearing like the 30-inch waist. If you're thinking of your graphs like in jeans sizes for whatever reason, then this is one of those examples where it gets skinnier. So we've got 4, which is greater than 1, so our graph has gotten skinnier. So let's check out the exact opposite of this situation. Number 35 says that v of x is equal to -1/5. Whoa, sorry about that. X squared. So let's get ourselves a graph to work with here. And let's plot it. So x, f of x, starting at 0. 0 squared is 0 times negative 1/5 is still 0. So 0, 0. So we're still starting at the origin. Let's try 1. 1 squared is 1 times negative 1/5 is negative 1/5. So we've gone down a very teeny tiny amount. Okay, let's see if this helps. Like that, maybe. So we've gone down a teeny tiny amount. All right, let's try 2. 2 squared is 4. 4 times negative 1/5 is negative 4/5. So we haven't even reached negative 1 yet. We've gone down very slowly. Negative 4/5. 3. 3 comes next. 3 squared is 9 times negative 1/5 is negative 9/5, which is not even to 2 quite yet. So something kind of like right here. Let's get a little further out there because we're not making much progress here. Excuse me, I can't speak today. So let's go out to 6. 6 squared is 36 times negative 1/5 is negative 36/5, which would be the same thing as negative 7 1/5. So 6 brings us down finally to a little bit past negative 7. So there, something like that. So here's the positive half of things as we start off super slowly. Then we start to pick it up a little bit eventually as we go on. Now let's see what happens on the negative side of things. Let's do negative 1. Negative 1 squared is positive 1. Positive 1 times negative 1/5 is negative 1/5. And you can already see that we're going to have symmetry again, right? Positive 1 is negative 1/5. Negative 1 also gives us negative 1/5. So we're going to have a symmetrical situation, and you'll always have a symmetrical situation as long as h equals 0, right? As long as h equals 0, the axis of symmetry is going to be at x equals 0, which is the y-axis. The only time that we move left or right is if we add or subtract something to x inside the square, inside the parentheses. Is if we don't move x within the parentheses, then we're going to be centered at x equals 0, or the y-axis. So you can see here, right? Nothing in the parentheses with x. The only thing getting that square is x. So we've got a symmetry at x equals 0 amongst the y-axis. So we can go ahead and use that symmetry. So negative 2 squared will be negative 4/5. Negative 3 squared will be negative 9/5. Negative 6 squared will be negative 36/5. And we've got ourselves a mirror image here. So you can see it's gotten quite a bit wider, right? Normally negative 3 or 3 squared negative, right? If we didn't have the 1/5 here, if it was just negative x squared, 3 squared is 9, and negative that would be 3. So normally we'd be hitting about here, but we've gone out wider. Our parabola has gotten fat, right? So if we look at our pattern here for number 35, the absolute value of a is less than 1, right? You can see that it's a fraction, 1/5. So the absolute value of a is less than 1, and a is negative, right? Negative 1/5. So it's an upside down parabola that got fatter. And we can see that here. It's upside down, and it got wider. So it's called scaling when we do that. When you multiply it, take a function and multiply it by some number or divide it by some number, as the case might be for number 35. That's called scaling. So when you scale a quadratic graph, when you scale a parabola, you're either going to make it skinnier or fatter, depending on if you're multiplying by something larger or smaller than 1. So I recommend taking a look at number 37 through 44. It's not technically part of the assignment, but I think it's a good way to test yourself. And also, it only takes like 10 seconds. So I say, while we're looking at it here, numbers 37 through 44 is a good way to make sure you're understanding the main concepts. And actually, I just had this thought before I started recording this video, but if I were to go back and reassign this unit, this chapter, whatever this assignment, I would have had you guys do 37 through 44, and maybe made you do a few less of actually graphing them. So the point of that little ramble there was 37 through 44. I recommend you do those just to make sure you've got this whole parabola manipulation stuff down. So, but the next actually assigned group of problems starts at number 45. So let's take a look at 45 here. Number 45 combines two of our previous concepts. So we've got an h and a k together here. So we've got y equals x minus 3 squared. So we have an h of 3 plus 2. So we have a k of 2. So we've got the full motion here. We're moving up and we're moving to the right. So let's revisit these two techniques. First, we've got a k. So if k is positive, we know we're moving up. And actually, just like we did in number 11, we're moving up by 2, right? Because k equals 2. In the case of h, right, in the case of the thing inside the parentheses, we've got x minus 3, so h is 3. And because we've subtracted, we know we're moving to the right. So h equals 3. So what does that mean? Well, k equals 2 means move up 2. H equals 3 means wow. My brain is not in math mode, apparently. I spelled axis like access. Axis of symmetry is x equals 3, aka move right by 3. So the plus 2 tells us to move up 2. The x minus 3 inside the parentheses tells us to move to the right 3. So what's that going to look like? It's going to look like this. So normally, okay, come on, computer. Give me one more question here. Stop it. There we go. Now we can see everything we need to see. Normally we'd be at 0, 0. We need to move up 2 and to the right 3. So start at 0, 0, and we've been translated up 2 and to the right 3. So we've got a dot there, right? Same thing. Normally we have 1, 1. Let's go up 2 and to the right 3. Wow, come on. There we go. Normally we've got 2, 4. So up 2 to the right 3. And then normally we've got 3 goes with 9, right? 3 squared is 9, so we move up 2 to get to 11, and to the right 3 gives us 6 comma 11, kind of right here. And then, like we saw from our h equals 3 situation, our axis of symmetry is now h equals 3. Or not h equals 3, excuse me, x equals 3. So this line right here is where the symmetry is. So it's going to be the same on the other side of that line. So we've got a 3, we've got a 6, and we've got an 11. So our parabola here for number 45 looks like this. So you can see we've taken our basic parabola and we've moved it up 2 and to the right 3. And let's just do a quick double check using x equals, oh my gosh, using x equals 0 here. Let's do a quick check with our original equation to make sure that it checks out. So when x equals 0, we have 0 minus 3 gives us negative 3. We square that to get a positive 9. And then we add 2 to get 11. Checking our graph, we have 0, x equals 0, y equals 11. So looks good. Everything checks out. So that's the story here for translation of these graphs. So I apologize for giving you so many graphs to do. It's not my fault. I took the recommended assignment from Parker. It's kind of my fault because I could have looked at it a little more closely. But get these graphs made. Let me know if I can help you with anything. If you do not have graph paper at your house, then there are several different varieties of free printable graph paper. Just Google it, free printable graph paper. If you don't have a working printer right now, then I sincerely apologize, but don't worry about being perfect, right? Don't worry about like drawing perfect lines and making a perfect graph, because then it'll take you hours to get this assignment done. If you want to do a little bit of rough estimation and just draw the general graph shapes without it being perfect, as long as you understand it, right? As long as you understand these concepts of the up and down movement, the left and right movement, the axis of symmetry, etc. That's what's most important about this, which is why I think 37 through 44 is a great way to quickly test yourself, because you're checking if you understand the concept without actually having to go through the process of creating all these graphs. So that's why I'm kind of a fan of 37 through 44. And I wish I had taken a closer look and assigned those problems instead of some of these other ones, but too late now. So before I forget, speaking of axis of symmetry, for the last chunk of problems, number 45 and 64, graphing is not the only thing it wants us to do. It wants us to graph the parabola. It wants us to graph the axis of symmetry, which I happened to already almost do here. So let's just finish it off. There we go. There's our axis of symmetry at x equals 3. And it also wants to get the coordinates of the vertex. So vertex is a term I haven't gone over quite yet, and that was a bit of an oversight on my part. So the vertex is the flipping point of the parabola. So either in the case of a positive parabola like this, it's the lowest point. In the case of a negative parabola, the vertex would be the highest point here. So the vertex is the center point, either at the top or bottom of the parabola. So normally, if we scroll all the way back up to our basic x squared here, the vertex is just 0, 0. So that is our standard quadratic vertex is 0, 0. So if we've moved up 2 and to the right 3, that means our new vertex is at 2, wait, nope, got that backwards, excuse me. Is at 3, because we moved to the right 3. comma 2, because we moved up 2. So you can use H and K here to figure out where our new vertex is. You use H to figure out where your axis of symmetry is. And it's pretty straightforward stuff. Let me just take a quick gander at the rest of these problems and make sure nothing looks like I'm accidentally tricking you. When you get to number 55, it starts to do the skinnier, fatter type of situation. So you might just have to make yourself a little table like this one, plot a few points, and then connect the dots, just like we've been doing. So when you're making a graph, if all else fails, just graph it, right? You have an equation, so graph it. But that's really all we're doing for this assignment is here's an equation, graph it. But you're going to start to get a feel for all of these situations where we're moving up, we're moving down, we're moving left, we're moving right, we're moving left and up, or in this case, we're moving right and up, we're moving in the X and Y directions. We're getting skinnier, we're getting fatter, we're flipping upside down, all of these things that we've looked at today for how can we, stretch and skew and move this graph about. So you are going to be very tired of seeing parabolas by the end of this assignment, but you're going to be very good at parabolas by the end of this assignment. So that's it. Have a happy Friday. Have a great weekend. And of course, never be afraid to reach out to me if you need any assistance with anything. And again, don't forget to Google printable graph paper if you don't have any graph paper at your house, because graph paper is going to make this assignment a lot easier for you. So have a great weekend, everybody.